Okay, well, I'd like to welcome everyone to the latest JFSP, IAWF, and Lessons Learned Center webinar. My name is Josh McDaniel. I work with the Wildland Fire Lessons Learned Center. I edit and write for one of the LLC websites, Advances in Fire Practice. And today I'll be introducing the speaker, Molly Hunter, and also moderating the question and answer session after the presentation. But first, I want to make a few quick notes. First, again, I'd like to point out the three sponsoring organizations of the webinar series, JFSP, the International Association of Wildland Fire, and the Wildland Fire Lessons Learned Center. I've put up some links to their websites here, and I invite you to, and encourage you to get on there and check out the growing set of resources on all three of these sites. Next, I wanted to let you know about some of the upcoming webinars. We're starting sort of a new approach to the webinars. We're going to be doing a dual series of presentations on one on fuels and air quality and smoke tools. There's some of the new tools that are available, and then also a social science series, and those will be going sort of side by side, and we're going to start having more frequent webinars hopefully, so you'll start getting a lot more notices about webinars from us. But the next webinar upcoming is Miriam Rohrig of the U.S. Forest Service's Air Fire team, and it's going to present in about 2 weeks, giving an overview of some of the new air quality and smoke tools available for wildland fire managers, FMOs, regulators, and anyone else who's concerned with smoke from wildfires and from prescribed burns. And then in January, Ivan Pupoletti of the Rocky Mountain Research Station is going to present some of his research he's been doing on human performance and risk management. So you can register for both of those webinars on the Advances in Fire Practice webpage. I've provided the link there if you don't want to type that all in. If you Google Advances in Fire Practice, you'll get there, or sort of navigate there through the Lessons Learned Center site. All right. Now and on to today's webinar. I'll introduce the speaker in just a second, but first I wanted to sort of let you know how a few things work. If you have a question, and we encourage you to ask questions, type it into the box on your control panel. It should either say questions or chat, depending on what version you're in, and then we'll get to those at the end of the presentation. We'll read them out, and then Molly Hunter can respond. Also, the webinar will be archived, and I'll put that link up towards the end of the webinar. And so first we record it and then put a link up on the Advances in Fire Practice page, and then it's archived on the Frames website if you're familiar with Frames for eternity, essentially. So we're gonna do something a little new. We're gonna try it. It's a little bit of an experiment. So I'm gonna do some polls to kind of find out who our audience is, and so bear with us while we try this. First time for me trying these, but I'll try the new bells and whistles. Okay. So you should have a poll up on your screen now asking who is your employer. So just go ahead and click on that, and we should be able to get a pretty quick response. Give it a couple minutes while everybody comes in. It looks like most people are starting to vote. Okay. Now I'm wondering how I show close and show results. Can I show results? Share. There we go. All right, so it looks like we've got 63% federal land management, 23% state or local, 12% NGO, 2% university or college. Okay. 3% private contractor consultant. Now let's see if I can get to the next one. All right, and so find out a little bit more about the audience. What is your connection to wildland fire? All right, okay, that's an interesting return. Okay, put that up. So 56% of firefighters are managers, 18% land managers, 11% researchers, 13% education and outreach, and 21% other. I guess we'll have to come up with some more categories to capture what that 21% other is. All right, and one last question. then we'll get on to the presentation. This is just to get some feedback on types of topics we can cover in future webinars, and just to get an idea if we're offering the right sorts of subjects. So go ahead and click there. Pretty even distribution. All right, I'll close it there. So there, put that up so you can see. So we got a lot of fuels folks here today, and seems to be a lot of interest in fire management policy as well. Okay, so now I will go ahead and introduce Molly Hunter. Molly Hunter is currently an assistant research professor in the School of Forestry at Northern Arizona University, and she focused her research on fire ecology and management in the Southwest, and teaches continuing education courses for fire management professionals. She also works with the Joint Fire Science Program on outreach and support for the regional fire science consortia that have been set up. That's another resource I'd like to point out to everyone there. The JFSP's regional fire science consortia, most of them are up and running now and starting to produce some really valuable resources, so I encourage you to check those out. But now I will like to welcome Molly, and I'll turn it over to her now and hand her the screen.
Okay.
Let me see if I can make the polls go away. There we go.
So, there we go. Lost my mouse for a little bit. Okay. So thank you, Josh, for that introduction and setting this up and all your troubleshooting. And thanks to everyone for joining us this afternoon. I wanted to start by just acknowledging my colleagues on this project. I worked heavily with Jose Eniguez, who's with the U.S. Forest Service Rocky Mountain Research Station, and also with Lee Lentile, who is with University of the South.
Molly, we're still not seeing your screen yet, I don't think.
Oh. How's that?
Yep, there we go.
There we go. Okay, sorry about that. So let me start. Let's see if there we go. Let me start by just giving some background on terminology. The types of fires that we examined in this study were resource benefit fire and prescribed fire. And resource benefit fire are what we're calling basically those fires that are ignited by lightning and are not actively suppressed, or basically are allowed to burn on their own accord. And I'm sure a lot of you are aware this has been labeled a number of different things in the past, including prescribed fire and wildland fire use. But for the purposes of our study, we're going to use this term resource benefit fire. In contrast to that, prescribed fire is any fire that's ignited or controlled by natural resource managers. And these are basically the two types of fire that we examined in this study. So there are many perceived trade-offs, I think, associated with this practice of resource benefit fire in particular. First of all, it's thought that the practice might be more effective at reducing tree density compared to prescribed fire, and there's a number of reasons for that. First of all, the timing of these practices tends to be a little different. Since resource benefit fires are ignited by lightning, they tend to occur in the middle of the summer. In the Southwest, that's the monsoon season, and that's when lightning storms are going to be more common. And this is really consistent with when one would have seen fires occurring historically in this area. Prescribed fires, on the other hand, are often likely to be initiated in the spring or in the fall, when weather conditions are more likely to support more moderate and controllable fire behavior. So it's thought that burning in the warmer summer months perhaps could lead to more intense fire behavior and thus higher tree mortality, and as a result thinner stands. And depending on the number and the size of the trees killed, this could be desirable if it does in fact create stands that are less prone to crown fire. Another perception is that the practice might be more effective at treating areas at a landscape scale compared to prescribed fire. And the reason for this is that the duration of the burning is often very different for these different types of fire. Since resource benefit fires are not suppressed, they have the potential anyway to burn for several weeks, and oftentimes they do. And over that kind of time frame, a resource benefit fire could spread to pretty large areas. Prescribed fire, on the other hand, typically is done over the course of a day or a few days because it's much easier to have control over fire behavior over that kind of time frame. And then it's also thought that fire behavior and effects characteristic of resource benefit fires is much more variable compared to prescribed fire. So if a fire burns over the course of several weeks, it's likely to experience a very wide range in conditions for fuels and weather and topography, and thus will result in a wide variety of fire behavior and fire effects. Prescribed fire, on the other hand, tends to really by design to burn with more low to moderate intensity and might result in more kind of homogeneous effects. And that heterogeneity that's potentially created by resource benefit fires could be desirable if it creates kind of unique wildlife habitat and those sorts of things. And there are also some perceived risks, I think, associated with resource benefit fire. For example, some have expressed concern that the higher fire intensity that you see as a result of resource benefit fire might deplete some important wildlife habitat features, so things like snags and large logs. Since these fires aren't suppressed, these fuels can burn until they're completely consumed, whereas in a prescribed fire situation, oftentimes managers will try to avoid these features to make sure that they're preserved. Another perceived risk is that resource benefit fire may result in fires that are of higher intensity than what would be considered acceptable. So large patches of high intensity fire can be undesirable for a number of reasons. They increase the potential for runoff and erosion and create opportunities for establishment of invasive species, among many other things. And by allowing fires to kind of spread on their own accord for several weeks, there is some concern that there's an increased potential for spread of really high intensity fire if conditions change and such that they would support that. So clearly there are some potential trade-offs, I think, associated with resource benefit fire, but we're calling these perceived effects, however, because there really haven't been very many studies that have really examined the effects of resource benefit fire. And this kind of information, I think, is really needed because more and more agencies are beginning to adopt this practice of letting naturally ignited fires spread. And we don't really know if resource benefit fire is more or less or equally as effective as, say, prescribed fire in meeting certain management objectives. So given that, we addressed, first of all, these two questions in our study. There's another question that I'll talk about a little bit later. But the first two questions we addressed are, one, what are the effects of recent prescribed and resource benefit fires in ponderosa pine forests, particularly in the Southwest? And by recent, we mean fires that are basically less than 5 years old. The second question is, what are the long-term effects of multiple resource benefit fires in ponderosa pine forests? So to successfully reintroduce fire into ecosystems, managers, I think, have to understand not only the short-term effects that result from fire, but also the long-term effects that result from repeated fires. It's been suggested that mimicking the historical fire regime in ponderosa pine of frequent fires as much as possible will result in forests that are more open, and more likely to support surface fire. And if we look at studies of long-term studies of repeated prescribed fires in places like northern Arizona, I think they support that notion. But similar evaluations of resource benefit fire are really lacking, which is why we wanted to address that, that question in our study. Also in Ponderosa Pine Forest in the Southwest, a common objective of fire management is to reduce loading of surface and crown fuels, ultimately to reduce the potential for crown fire. So with that in mind, the effects that we focused on in particular were the effects of these fires on surface fuel loading, on stand conditions, and on potential fire behavior. And that's potential fire behavior as predicted by fire behavior models. And we addressed those questions in the Gila National Forest, which is in west central New Mexico. And the Gila provides a really unique landscape to address some of the unknowns surrounding prescribed fire and resource benefit fires, because they have a very long history of allowing naturally ignited fires to spread. This dates back to the early 1970s. It was one of the first places in the country that adopted this practice early on, and it's maintained the program ever since. And the program originally started in the wilderness areas, which are shown in the dark green on this map. But more recently, they've also expanded the program into areas outside of the wilderness area. In particular, areas just kind of north of the Gila and the Aldo Leopold wilderness. So with that kind of rich history, I think the Gila provides a really unique setting to examine some of the short and the long-term effects of resource benefit fire and prescribed fire. Here's a map of our study area. So the areas that are in gray represent areas that have burned in some type of fire event in the last 60 years. And the areas outlined in blue, you could see they're labeled the Johnson and Martinez wildland fire use fires. Those are what we're calling recent resource benefit fires. And the areas outlined in red, the Sheep Basin and the Eckelberger, are what we're calling recent prescribed fires. So for our first study question, what we did is we examined and compared the effects of these recent resource benefit and these recent prescribed fires. For the resource benefit fires, we also stratified the area by fire severity using some burn severity maps that were available to us. And we opted to establish plots in areas that were classified as both low and moderate fire severity. And we did this because we obviously would expect different effects in areas that burn with different intensity, and we wanted to be able to capture some of that. We didn't do the same kind of stratification in areas that were burned in prescribed fire because all of those were classified as low severity. And then in addition to that, we established some unburned, some plots just outside the fire perimeters to serve as sort of unburned control areas. And for the areas that burned in multiple fires, we focused on the area towards the bottom of the map. The black and the orange or the red triangles here represent areas that have burned in either 2 or 3 resource benefit fires in the last 60 years. And these are areas that are basically just kind of north of the wilderness area. So here's some additional data on those fires that we examined, and it also kind of shows our the breakdown of our treatments. We looked at 2 prescribed fires, both of which occurred in the fall, and all of the resource benefit fires that we looked at occurred in the summer. And the prescribed fires burned with low severity, while the resource benefit fires burned with both low and moderate severity. So the resource benefit fires we stratified by severity, establishing plots in both low and moderate severity. And then we also examined areas that had burned in either 2 or 3 resource benefit fires in the last 60 years. And for the areas that had burned in multiple resource benefit fires, we didn't do any stratification by fire severity because burn severity maps weren't available for some of those older fires. So we looked at a number of variables, but here are the ones that I'll discuss today. First of all, we assessed fire severity using the composite burn index. And this is an index of fire severity based on basically a composite of fire effects on many factors. So it includes fire effects on soils, fuels, vegetation, and canopy fuels. And it gives a rating essentially from 0 to 3, with 0 representing no fire effect and 3 representing high fire severity. We also looked at fuel loading for all size classes of fuels, and we examined various stand metrics, including basal area, tree density, and density of tree seedlings. And all of these data were collected in the summer of 2008, so this would have been 2 or 3 years post-fire. We also wanted to examine the effects of these different practices on mitigating potential fire behavior. And namely, that was the potential for ground fire spread, because that's typically in these systems what managers are trying to prevent. So to do this, we first needed to get some estimate of canopy fuel loading, and the variables that are typically used in fire behavior models are canopy bolt density and canopy base height. And canopy bolt density can't be measured directly short of cutting down trees and weighing their biomass, so instead it needs to be estimated in some way. And there is a lot of uncertainty associated with the best way to estimate canopy fuel, so we opted to look at a couple different methods. First, we used allometric equations that have been developed by Brown, and we used that to get at canopy fuel weight and bolt density. And then we also used stand level regression equations that were developed by Cruz et al. And then another variable that's needed is canopy base height across a stand, and we opted to use the 20th percentile canopy base height across a stand, because other studies have shown that using a minimum or the average value across a stand can under or over predict the potential for ground fire initiation. So all of those variables, again, are used in models that predict potential fire behavior. And we opted to use the ground fire prediction model Nexus to examine the potential for ground fire spread and initiation in these different stands. We assumed 90th percentile weather conditions, and basically what we assessed with this model was the type of fire that was predicted under the conditions for the various stands. So this would include basically a surface, passive, or an active ground fire. A surface fire, of course, burns through the fuels on the surface of the ground. A passive ground fire, also called torching, burns through just one or a few trees but doesn't actively spread through the stand. And an active ground fire actively burns through the crowns of trees. And typically for this forest type, what a manager is going to want is a stand that will support either surface or passive ground fire. And an active ground fire is much more difficult to control and leads to much more severe fire effects, and it's not characteristic of how these forests would have burned historically. So here is our plot design. It consisted of 2 nested circular plots. In the larger plot, which was 16 meters in diameter, we measured variables for all mature trees and saplings. So this included things like tree height and DBH and crown base height. In burned plots, we also assessed fire severity using the composite burn index in that larger plot. And then in the smaller subplot, which was 8 meters in diameter, we counted the number of tree seedlings. And then from the center of the plot, we established 3 25-meter transects on which we measured fuels and vegetation. And the fuels were measured using the Brown's methodology, and vegetation cover was basically measured in two subplots along each transect. So in the following tables, what we're showing here is the average conditions for unburned areas, for prescribed fire, for resource benefit fire of low severity, and that's recent resource benefit fire, for recent resource benefit fire of moderate severity, and then areas that burned in 2 or 3 resource benefit fires in the last 60 years. And the numbers in parentheses next to the treatment label are the number of plots that we had in each category. And then the numbers below in the table basically represent mean and standard error. So here are our results for fire severity, which is represented by, again, the composite burn index, or CBI. And just a reminder, the CBI is an index that ranges from 0 to 3, with 0 indicating no fire effect and 3 indicating high fire severity. So one thing to point out, of course, it's not surprising that areas classified as moderate severity had a higher CBI than areas classified as low severity. But what I think is more interesting in these results is the comparison between prescribed fire and resource benefit fire of low severity. So while both of these areas resulted in a CBI that would be considered low severity, there was a significant higher CBI value in the resource benefit fire of low severity compared to prescribed fire. So this is giving us some indication that that resource benefit fire is in fact leading to slightly more severe fire effects than prescribed fire. Now these are the results for stand characteristics, and what we're looking at here is the same treatment categories, but now we're looking at basal area, trees per hectare, and tree seedlings per hectare. And again, if we compare certain stand characteristics, there does seem to be slight differences between prescribed fire and resource benefit fire. And pay particular attention to resource benefit fire of low severity. So for example, if you look at basal area, it was significantly lower in areas of low severity compared to prescribed fire. And it looks like that you see sort of the same trend for both trees per hectare and tree seedlings per hectare, but the differences between prescribed fire and resource benefit fire of low severity weren't significant. Another thing we can see, I think, from these results is that lower stand density seem to be maintained in areas that burn in multiple resource benefit fires. So if you look at, for example, trees per hectare in areas that burn in 2 and 3 resource benefit fires in the last 60 years, it's much, much lower and significantly lower than areas that have been unburned, long unburned, at least in the last 60 years. Now let's look at some of the effects on canopy fuels and potential fire behavior, and let me start by just describing what some of these variables are. So CBD there stands for canopy bulk density, and we have 2 different measures of canopy bulk density. So CBD stand there refers to canopy bulk density that's calculated using stand level regression equations. CBD allometric refers to canopy bulk density that's calculated or estimated using allometric equations, and those are the ones developed by Brown. CBH20 is the 20th percentile canopy base height, and then fire type is basically the type of fire that's predicted in Nexus given the different methods we use to estimate canopy bulk density, so the stand equations and the allometric equations. So what these results show, I think, is that resource benefit fires, again, do seem to be a little bit more effective at reducing the potential for crown fire, and that lower potential for crown fire seems to be maintained with multiple resource benefit fires. However, the results do depend on the method that we use to estimate canopy bulk density, and this has been something that's been shown in other studies as well. So let's start by looking at the CBD stand, or canopy bulk density measured, estimated using stand level equations. You can see that the bulk density is significantly lower for all resource benefit fires regardless of severity or frequency. In all cases, it's lower than both prescribed fire and unburned areas. So, and there's no significant difference between the unburned areas and the prescribed fire. So as a result of that, the type of fire that was predicted in those scenarios, you can see down at the bottom that an active crown fire was predicted for unburned areas and areas that only experienced a prescribed fire, whereas a passive or a surface fire was predicted for areas that experience any kind of resource benefit fire. So that's showing that resource benefit fire might be a little bit more effective at reducing the potential for crown fire. However, if we look at the allometric estimates of canopy bulk density, there's no significant difference among any of the treatments with the exception of resource benefit fire of moderate severity. Only in that case did we get significantly lower canopy bulk density. But in that case, when we plugged those numbers into Nexus, we had a passive crown fire that was predicted for most scenarios, except for resource benefit fire of moderate severity and areas that had burned in 3 resource benefit fires. The model predicted a surface fire. So even in that scenario, it does actually suggest that areas that experience multiple fires have a lower potential for crown fire. One of the more surprising results we found was that fuel loading did not vary across our fire treatments regardless of fuel size class. And I thought this might be because the areas that we sampled were, we sampled 2 or 3 years after the fire. So that would have probably allowed some time for accumulation, at least of smaller fuels. What it does indicate, though, that I think is important is that these fires don't seem to have any significant impact on larger logs, which of course are important for wildlife habitat and a number of other things. So now I want to shift gears a little bit and talk about a third question that we addressed in our study, which is somewhat related. The third thing we addressed was what are the effects of resource benefit fires in Pinyon-Juniper woodlands. So we decided to look at this because fire effects and behavior have been studied a great deal in ponderosa pine forests in the Southwest. However, there's really much less that's known about fire effects in Pinyon-Juniper woodlands. In general, the use of prescribed fire has been a lot more limited in these systems because the fuel structure is not very conducive to low-intensity fire spread. And unlike ponderosa pine forests, most Pinyon-Juniper woodlands in the Southwest historically probably burned with infrequent and much higher intensity fire. In the Gila, recently, some extensive areas of Pinyon-Juniper woodland have burned in some resource benefit fires, and they burned with both low and moderate to high intensity. And we thought that this provided a good opportunity to gather some information on the effects of fires in these systems. So that's what we did. And again, the particular effects that we focused on were the effects of these fires on surface fuels, on stand characteristics, and then on potential fire behavior. And for this part of the study, we again looked at recent resource benefit fires that burned in the summers of 2005 and 2006. These fires burned in not only in ponderosa pine areas but also in some Pinyon-Juniper woodlands, and they burned with both low and high severity. So again, we stratified these fires by fire severity, looking at areas of both low and moderate severity. And this part of the study did not address prescribed fires because it's not typical to conduct prescribed fires in this vegetation type in the Gila. And also it didn't address the multiple resource benefit fires because there really aren't many areas in the Gila where multiple fires have burned through pinyon-juniper woodlands. So we did, in this case, find an effect of these fires on, at least on 1 hour fuel loading. We found that fuel loading was significantly lower in areas classified as moderate severity, but there was no significant difference between areas classified as low severity and unburned areas. And we also found that there was no significant difference in fuel loading among these treatments for any other size class of fuel, so indicating that the resource benefit fires in the system didn't have any effect on those larger fuels. Similarly, we found that the moderate severity fire resulted in significant changes in stand characteristics. So for example, for all of these characteristics that we measured, the basal area, density of mature trees, and density of tree seedlings, we found that there was only significant reductions in those variables in the areas classified as moderate severity. And there was no significant difference between unburned areas and areas classified as low severity. In terms of potential fire behavior, again, we found some pretty similar results in that there was really only a significant effect of the fire in areas that were classified as low severity. So for example, if we look at canopy bulk density, there was no significant difference between unburned areas and areas that were classified as low severity, but there was a significant reduction in areas classified as moderate severity. The canopy base height was only significantly raised in areas, again, that were classified as moderate severity. And then the type of fire that was predicted in Nexus was independent crown fire in areas that were unburned or burned with low severity, and then a surface fire in areas that were classified as moderate severity. In this case, we didn't look at stand level regression equations to estimate canopy bulk density because those have not yet been developed for pinyon-juniper woodlands. Okay, so in conclusion, our results show that, at least in the Gila National Forest, low intensity resource benefit fire and prescribed fire did produce pretty slight differences in terms of canopy fuels, and those differences did translate into a difference in the potential for crown fire initiation and spread, at least under the conditions in which we modeled. Of course, prescribed fire and resource benefit fire also differ substantially in that resource benefit fires often result in patches of fire that burn with really high intensity. And that could be desirable or not depending on the size of that patch. So relatively small scale patches might create heterogeneity on the landscape and might be desirable in that respect. But large scale patches might be detrimental for wildlife habitat and create much more erosion and runoff and would be not desirable. In the fires that we examined, the size of all of the moderate severity patches were relatively small. So even in this case, I think they were not considered undesirable. Another important thing we found was that the lower stand density seemed to be maintained in areas that experienced multiple resource benefit fires in the last century, or in particular in the last 60 years. And consequently, a lower potential for crown fire was also maintained in those areas that had experienced multiple fires. And finally, when we look at fire in pinyon-juniper woodlands, low severity didn't really produce any detectable effects on fuels or potential fire behavior. Only in areas that were classified as moderate severity did we find significant effects in these PJ woodlands. And while the effects were pretty significant in those areas, they probably aren't inconsistent with how this vegetation type would have burned historically, or the types of effects that you would have seen historically. So what that first conclusion shows us, I think, is that managers do, in fact, I think, have multiple tools at their disposal when trying to move forests into more sustainable conditions. And by sustainable, I mean less prone to crown fire, because that's typically what people are trying to avoid, at least in these systems. In the Gila, it appears that both prescribed fire and resource benefit fire have similar effects on surface fuels. But it also seems that resource benefit fire is slightly more effective at reducing tree density and reducing the potential for crown fire. And to me, this suggests that the goal of reducing the potential for crown fire could be effectively achieved with resource benefit fire, and perhaps also with a little bit higher intensity prescribed fire, or maybe even low to moderate severity wildfire. And I think our second conclusion reminds us that reaching these more sustainable conditions requires a long-term commitment to management, because we saw that those desirable conditions of lower stand density and less potential for crown fire were maintained in areas that had seen repeated fires. And we saw similar effects in those recent resource benefit fires that we looked at, but it's not likely that those conditions are going to be maintained in the absence of fire over time as fuels accumulate. And finally, I think our results show that use of low-intensity prescribed fire is probably not a real viable option in Pinyon-Juniper woodlands, at least the ones that we examined in the Gila. The fuels in this vegetation type just don't really support low-intensity fire spread, and by their nature, this vegetation type tends to burn infrequently with fairly high-intensity fire. And then finally, I want to end by just acknowledging a few folks. First of all, this study was funded mainly by the Joint Fire Science Program, but we also got some support from the U.S. Forest Service Rocky Mountain Research Station and the NAU School of Forestry. We had two great field assistants, Kevin Keith and Zeb Andrews, and we had a lot of support from Gila National Forest personnel, in particular Toby Richards and Pete Delgado. So with that, I guess I'll send it back over to you, Josh, to moderate some questions.
Okay. Well, thanks, Molly. That was really interesting. Let me I'll go ahead and dive right into the questions, and encourage anyone out there that has a question, go ahead and type it in, and we'll start working through the list. The first question is more of a comment, and it's from Frank Fay, and he says the term resource benefit fire is problematic with federal fire policy. You might try acres treated by wildfire, and so that sort of brings up the rapid changes in terminology. The types of question you're addressing there's been some changes, a lot of changes in the recent years, and so maybe you can address where it's settled.
With this particular study, terminology's been been quite a challenge.
Yeah. Okay. Mary Huffman has a question, and she says, what will it take to replicate the Gila's tolerance for resource benefit fire on other sites? And maybe you can expand on that and talk about other areas of the country or of North America maybe that are starting to have some of the same types of same level of commitment to these types of programs.
Yeah, I think a lot of it has to do with personalities, and one of the reasons the program that got started early on in the Gila, certainly its remoteness played in its favor, but I think there were also just some personnel that were there early on that were committed to the program. But I also, and I think over time, there's been a lot of institutional confidence that's developed with more and more experience that's been in the Gila. But I've noticed more recently, talking with managers in places like the Kaibab National Forest and the Coconino National Forest, where they're starting to implement a lot more of limited suppression on wildfires and things like that. And I think by just the more you do it, the more kind of organizational confidence develops, which is helpful. And then and just having people in place that are committed to it.
Right. Is that, I know the Gila probably has the longest history of these types of fires. Have there been similar studies in some of the more recent units that have had these types of programs where they can start to say that the resource benefit fires are starting to have an impact on fire behavior, or is the Gila sort of the only one that has that sort of length of history that you can start to make some analysis?
No, there's similar programs that also are, in Yosemite there's a program that's even older than the Gila, and there's been studies that have looked at the effects of fire there. But in terms of recent programs, I think there are people that are looking at some of the fires, for example, in the Gila National Forest. I'm not aware of anything that's been published to date, but I do think that there are people paying attention to it.
Okay. Mary Huffman has another question, and she says, we seem to have a love-hate relationship with trees and fire. Love thinning dense stands, but hate dead trees. Hate active crown fire, but love thinning. How do managers on the Gila reconcile these otherwise paradoxical values?
Well, I think the Gila is somewhat unique in that because they are remote, they don't necessarily have as much public pressure as what you would find in other areas. So I think in the past they've been able to get away with maybe seeing a few more dead trees on the landscape because they don't get people, they just don't see as many people out in the woods that would complain about things like that. But I think that there's other examples of places where they've overcome some of those stumbling blocks by just educating the public and when people. Another thing is just the public has to just kind of get used to these things, and I think the more and more they see them, the more over time the more acceptance is gained.
Okay. Mary Lotta has a question, and she says, I was wondering if/how severity levels were attached to the first, second, or third fire in those areas that had more than one fire.
We didn't have any severity, any information on severity for those fires. Is that kind of what the question?
Yeah, I think so. Yeah.
Yeah. So unfortunately, some of those fires were a little bit older, and we didn't have burn severity maps available, which is why we didn't do any kind of stratification there. But we did. Some data that I didn't present is that we looked at some other measures of fire severity on the ground, like looking at if we could figure out how many fire-killed trees there were, and scorch height and char height and things like that. And the areas that burned in multiple fires weren't, at least on the ground, didn't appear any more severe than the recent fires that we looked at.
Okay. Matt Ehrman has a question. He says, towards the end of your presentation, you mentioned that moderate intensity prescribed fire may be able to achieve the same results as resource benefit fire. Are there examples of that type of prescribed fire treatment as opposed to the low intensity prescribed fire looked at in this study? So is the Gila doing moderate intensity prescribed fires, I guess is the question.
Well, the particular ones that we looked at were a little bit lower severity, but I would imagine that doing higher intensity fire is something that they would be very comfortable with. I'm not aware in particular if there's fires out there that they've completed with a little bit higher intensity. I think there are examples elsewhere though, like in the Grand Canyon, they've managed some fires, prescribed fires that are a little bit higher intensity, and they've kind of had to do that because fire is the only tool that they really have. So I think there's one example of a place where they seem to be be able to meet their objectives pretty effectively with just higher intensity prescribed fire.
Okay. Anita Bueno has a question, and she asks, what does a low-intensity resource benefit fire versus a prescribed fire look like? Can a casual observer tell them apart on the landscape? So maybe just a quick description of what a resource benefit fire is for folks who aren't familiar with that.
So you mean like what the fire behavior actually might look like?
Yeah, maybe so, yeah.
Okay. Well, I mean, I've observed some resource benefit fires that really just, in some cases, just sort of creep through the litter and duff, and you may not even see much of a flame during the coolest parts of the day. Whereas, moderate intensity, I think, is when you start to see higher flame lengths, upwards of 4, 5, 6 feet that start to sort of scorch the needles in the trees and kind of prune the lower limbs of the trees. And then high intensity fire is going to be when the fire starts to get into the crowns of trees, either through some I think moderate can be considered maybe a few torching of trees, and then really high intensity would be when you start getting crown fire, active crown fire spreading through the trees.
Okay, Anita asked to sort of expand on the question. She's wanting to know, she was more talking about the results, so like, after the fire is over, what are the effects?
So I think low severity effects, typically you might see some consumption of your smaller fuels would be an example of an effect, but probably not much of an effect on the larger fuels. In terms of the canopy, I think low severity would indicate very minimal effects on canopy fuels. And as we start getting into moderate and higher intensity, moderate might include at least some tree mortality, but probably not killing off of an entire stand. It would also include probably consumption of a little bit larger fuels, so getting into your 1 hour or 100 hour and 1,000 hour fuels. And then with high intensity or high severity, you see much more consumption of the larger fuels and much more tree mortality.
Okay. So Chris Singer asked, were you able to quantify the variability of the resource benefit fires, and if not, do you have plans to, and how?
The variability in terms of the effects, fire severity?
Doesn't say. Go with that.
Well, what we do have is, I think we have a paper on this that's coming out hopefully in next month in Fire Ecology, and we do discuss kind of the range of effects a little bit that we saw. In the fires that we examined, there was very little high severity fire. Less than 3% of the entire perimeters of those fires would be classified as high severity. So the range of the effects was a little bit low in that regard. But we do have, we did see, I guess, the full gamut of CBI estimates, everything from 0 to close to 3. So there was kind of a wide range of effects, but I would say most of the areas within those fires were kind of in the middle of the moderate and low severity classifications.
Okay.
I hope that answers that.
Hey, Chris, if that didn't, just send me another. Oh, let's see. Yep, I think that got it. Okay. Brian Ebert asks, were any of the prescribed burn treatments multiple entry burns? I'd be interested to know if multiple entry burns would result in continued thinning of tree density, closer to moderate intensity resource management fires looked at in the study.
Yeah, that's a good point. These were first entry burns, but I suspect that that with multiple entry burns, you would start to see more more mortality and effects that were closer to the moderate severity. And again, if we could talk about the Grand Canyon again, I think that they they do tend to see more effects with their multiple entry fires. They have many areas that they've treated, 2 and 3 times, and I think they do kind of see continued mortality as they progress in their treatments.
Okay. Paul Woodward asks, he says, I believe in your last table you used the terms intermediate, or was it intermittent, versus surface. Please define the term intermediate fire. And you might have already done that, but maybe just real quick.
So in the last table, actually, what was predicted was an independent crown fire. And in Nexus, that is basically a classification for fire that spreads would spread through the canopy of trees, indicating that the crowns are dense enough to support an active crown fire. But the surface fuels were such that a crown fire wouldn't initiate from the surface, so the fire would have to initiate from basically an adjacent stand. So it's not something that you, I think, see very often in nature, but it's one thing that is an output in Nexus. For our purposes, I think it's kind of equivalent to an active crown fire. It just means that in that case, the surface fuels are so low that they wouldn't really support much of a surface fire, or enough of a surface fire to get the fire into the canopy.
Okay. Catherine Hetz has a comment, and I think she's wanting to put a plug in for the program at Lewis and Clark National Forest. She says the Lewis and Clark National Forest has many examples of successful, effective, multiple objective fires in addition to prescribed burns burned under conditions of moderate intensity and severity. Or are we strictly limit our discussion to forest types in the Southwest? I would say no. Certainly welcome information from any forest experimenting with these types of programs. Patrick McElvey has a question. I would appreciate her comments on what success looks like from a resource benefit fire. It seems like it's easy to see that more in results from It seems like it's easy to see that more in results from prescribed fire use than it is from resource benefit fires. It has implications for how we communicate success, measure success with the public at large. The public knows how to measure success from suppression actions, but not from resource benefit fires, for example. So, how, whenever a unit is managing a resource benefit fire, how do they describe what they're trying to accomplish, and then how successful that was?
Well, I think one of the things that can be helpful is I know that in the Gila that they have, for example, a target for how big they want high intensity patches to get, or so, they have kind of a threshold that they would like to maintain, and I can't quite remember what it is, but obviously you don't want patches of high severity that are very large, at least in these systems. So they have kind of a maximum number that they like to attain, and I think that's one thing that can be helpful to communicate to people, because oftentimes if they see any mortality or any kind of high intensity big patch of dead trees, it might be considered negative to them. But if you can explain that actually this is still much smaller than what our threshold is, and ultimately it's going to create an opening and probably some wildlife habitat and things like that. So if you have some targets for things like that, particularly for those things that people don't quite understand what the benefits can be, I think that can be really, really helpful.
Okay. Kevin Hilliard asked, was month of burn considered or just season?
We just considered season.
Okay. Well,
and some of these fires burned for, over the course of a couple months. So.
Okay. Well, that's all the questions we have, so we'll go ahead and wrap it up there, and we're coming up to the top of the hour anyway. So first I want to thank Molly. I think it was a really interesting presentation, a lot of good information there. And we're hopefully going to be hearing from Molly in the future. She has volunteered, and since we're saying it publicly now, I guess we're locking her into that volunteering to make some presentations updating on recent research reports submitted to the Joint Fire Science Program, so sort of the latest and greatest stuff coming out of JFSP. So we look forward to that as well. So thank you, Molly.
Sure.
And everyone else, if you're wanting to pass this webinar on to someone, there's a recording being made of the webinar, and we'll have that on the Advances in Fire Practice page here shortly, as soon as I can get it uploaded. And you can also find registration information for future webinars out there. And thanks everybody for coming.